All right, so number 8 says, what are the solutions? And then they give us an equation. Well, as we talked about in the last problem, solutions, when they ask for what are the solutions, they're asking what are the x-intercepts. They might interchange the word zeros, what are the roots. But basically, it means all the same thing, which is that given this equation, where does that equation cross the x-axis? And as we looked at in the last one, we could do two things. We could always throw this into our graphing calculator. So we could do 2x squared plus 2x minus 5. And as we've said before in other videos, all we're doing is we're just getting a sneak peek at what we think the answer might be. So we got a parabola that looks like that. The problem with this one, though, it looks like, I mean, maybe that's 1, but it looks like maybe a little more than 1. That looks maybe a little bit to the left of -2. So it's kind of hard for me to tell exactly where that is. It might be because it doesn't go through a whole number, or it could be that just the TI-84, this picture is so pixelated and it's hard to read. So as we mentioned in other videos, that's why we've got a backup, is we've got our buddy Desmos here that we can plug the equation into and see what it's going to look like. So I don't know. Let me throw that in there. 2x squared plus 2x minus 5. Let's see what this is going to look like. And again, we're kind of getting the answer before we do the problem, so we know what it's going to look like. So there's some other information here about the vertex and the y-intercept. What we're focused on are what are the roots. So it looks like where it crosses the x-axis is a little more than 1, and then a little less than -2, which is what we said here. With this one, it just was harder to read. Okay, so these aren't whole numbers, so that's going to kind of mean something here in a second, and we'll kind of refer back to that. But so let's try to do it by hand. We know what the answer is going to be already, but let's see if we can crank this out by hand. We said you got two options, right? So to solve, if you want to solve, you've got two options. You can factor, which is what we've done on the last couple, right? With doing, using this method right here. Or there's a second option, which is to use the formula. We said that factoring, in a lot of cases, it ends up being less work. So we always want to see if we can factor it first. So here's my A, B, and then C. So let me see if I can factor this thing. So A times C, right, which would be -10, right, because 2 times -5, -10, and you got a 2 on the bottom. I'm looking for two numbers that multiply to -10 that add up to 2. Well, so I could do 10 and 1 and then play with the signs, but that won't get you anywhere near adding up to 2. The other way I can multiply to 10 would be 2 and 5, or 5 and 2. And again, I can play with the signs, but that's not going to get me to add up to a +2. So what happens here is that this one cannot be factored. So some things are prime. Right, some expressions are prime. Some expressions cannot be broken apart any further. So what we end up doing is that if you can't factor, we're going to use the formula. So we're going to use the formula when you can't factor. So when you can't factor. Now I will say this, there are some people that prefer using the formula every single time, and you can do that. Factoring works for some, but not all. The formula works for all, right? So this one works for every problem. So it works for every equation. Some people like kind of the security and the safety of that, of knowing that, okay, I know if I use the formula, it's going to work every single time. Whereas if I factor, it's kind of a crapshoot. Maybe sometimes it works, sometimes it doesn't. So, on this, for instance, the one we did before, we could have used the formula on this one. It just worked out that we could have factored it. So it really becomes a personal preference. Mine is to factor first and then use the formula only if I have to. But that's a total individual thing. If you like using the formula, then rock on with your bad self. All right, so we've already established we can't factor, so we're going to use the formula on this one. So I've got x equals, oh, we didn't even say what the formula is. We should write that down. So the formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, and that's all over 2a. You can search YouTube. You'll find quite a few quadratic formula songs that people have done. Traditionally, it's done to Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the last time I'll sing. I won't sing anymore. But it is kind of, because you have to think about it, like you got to memorize all that, and that's kind of tough. So, the brain likes putting things to music, right? Think about how you learned the alphabet. When you're in kindergarten or around that age, right? It was put to a song. So the brain likes that. If we put things to music, helps it remember it. So but even if you have it memorized, I still write it down just so that, like, as I'm plugging in numbers, I'm making sure that I'm getting it in the right thing and I'm not having to do it from memory. So we've got negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All I did here is I wrote out the formula, and I'm just leaving some blanks that I'm going to fill in. So what you see here in black, this is, no matter what these numbers are, this part will always be there. And now we just got to fill in. So negative b, well, b is 2, plus or minus b squared, 2 squared, minus 4 times a, our a in this case is 2, times c, which in this case is negative 5, and then that's all over 2a, which again our a is 2. Now there's a couple different ways you could do this. What you could do is that now that you've got everything plugged in, and I would caution you, by the way, to not trying to do too much stuff mentally here, because it's really easy to make a mistake. So I would encourage you to fill it all in first and then start crunching the numbers. So what I can do is I could say x equals negative 2 plus or minus, and I'm going to start simplifying what's underneath the radical here. So 2 squared, which is 4, minus 4 times 2, which is 8, 8 times negative 5, which would give us a negative 40, and then that's all over 2 times a, which 2 times 2 would give me 4. And I'm just going to scroll down the page here a little bit. Whoop, maybe too far. And again, I'm going to keep simplifying what's underneath the radical. Next thing I can do here is that a minus and a negative, those two things turn into one big plus. So that would really turn into 4 plus 40, which would give me 44. Okay. So you notice here I don't get something that's a perfect square, so I can't take the square root of it. Well, I can, but it's going to give me a decimal. And that's what I said earlier about, hey, aren't these guys decimals? They're decimals. So that is connected to why the graph, the x-intercepts are decimals, and we get something here that would give us a decimal. So what do? I could do, if I separated this out, I could say negative 2 plus the square root of 44 over 4, or x equals 2 minus the square root of 44 over 4. I don't know, take a wild guess. If we did 2 plus the square root of 44 over 4, if we threw that in the calculator, what do you think we might get? I'm thinking we might get 1.158. Let's verify that. So I'm going to put that in the calculator. I'm going to do 2 plus the square root of 44, and then that's all going to be divided by 4. And if I just type it like that, the calculator is probably going to think I mean square root of 44 divided by 4. But notice that that whole piece is in the numerator, is on the top part of the fraction. So just so that the calculator gets the order of operations right, let's use parentheses. So I'm going to say 2 plus the square root of 44. We're just separating that out. and then all of that divided by 4. Right? And then what we end up getting there is 2.15. Hey, wait, wasn't I supposed to get 1.158? Wait, so these numbers aren't matching up here, right? So I got, let's get the calculator back over here. Sorry, hopefully I don't make you sick. I got 2.158, but it's like, oh wait, I thought that was supposed to be a negative 2.158. Or I thought it was supposed to be 1.158. Wait, so something's not right here, right? Well, so this is why I actually, you may not believe this, but I actually made this mistake on purpose because I wanted you to see the value of why it's good to graph it first to know what the answer is, so that if you get something that doesn't match, you can say, hey, wait, something's not right here. One of the reasons why I don't like the quadratic formula, or the reason why I prefer factoring, is that with quadratic formula, usually there's a lot of steps here. There's a lot of little moving parts, a lot of little add this, multiply that, divide this. So there's a lot of little different areas or places that you can make a mistake. Notice what my mistake was. I've got negative 2 plus or minus the square root of 44 over 4. Look what I wrote right here. I wrote a positive 2. So that should be a negative 2. So this is a mistake that's really easy to make with the quadratic formula, because you're writing all of this and then recopying it and recopying it and recopying it, and sometimes you can make a mistake doing that. So let me try this again now that I've caught my mistake. But again, I wanted you to see that's the value of knowing what the answer is first, is you catch yourself from making a mistake. So square root of 44, and then that's going to be divided by 4. There we go. So now this time we got the answer that we were looking for. So we were looking for 1.158, and yep, I got 1.158. Now here's the deal. Desmos actually rounded it. You notice this decimal keeps on going, and you're like, well, wait, do I have to write all that? Well, so the thing is that we don't want to have to mess with writing all of that decimal out. So what we do is that we actually keep it in what we would call radical form, meaning that we're actually just going to keep it like this so that I don't have to write out all the decimals. Now, there is one thing we can do if we're going to keep it in radical form, right? So if we're going to keep it looking like this, is that this is a fraction, kind of maybe a weird looking fraction, but it is a fraction. And like with any fraction, we always want to reduce the fraction if we can. So that's what we're going to do here, is that if we're going to keep our answer like this, which, like I say, is an alternative, we could have written our answer, x equals 1.158. We could have written this out as a decimal, and if we crunched out the numbers on that one, we'll get negative 2.158. So we could write our answer that way, but traditionally what happens is that it gets left in radical form. You'll most commonly see it like this. So it's only if we have whole number answers, like what we did, let's say on the last couple problems, where we had a whole number answer. But if we're going to get some nasty looking decimal, in a lot of cases we prefer to keep it in radical form. Now, what I do want to do with this, though, is see if I can reduce the radical. So how would I do that? Well, so the square root of 44, let's go to the side. We're going to do a little kind of scratch work here. Square root of 44 is not a perfect square, but if we do a little kind of factor tree and we say, well, what times what makes 44? Well, how about the square root of 4 and 11, right? Because 4 times 11 gives you 44. Now, 44 is not perfect, but if I break him apart, I'm looking for something that is. Well, 11 is not perfect. However, right, square root of 4, that is perfect. I can take the square root of 4. The square root of 4 is just 2. No square root 2, just 2. Now 11, he's not perfect. He can't be broken apart, so he just would stay inside there. He just would stay as radical 11. So what I can do then is I can write this as negative 2 plus or minus 2 radical 11 over 4. By the way, I don't know if I mentioned this. the fancy math word for that symbol is called the radical. In this case, it is actually the square root, but sometimes we don't always take the square root of numbers, right? So if I said something like that, I'm saying what number times itself 3 times would give me 8. So we don't always take the square root. In this case, it is, but so that's why we use this word radical, and it's pretty fun to say. All right, so now what I want to look at is that, well, can I reduce anything? Oh, okay, well, I can divide each one of these numbers by 2. So what I can say is I can say -1 plus or minus 1 radical 11, which 1 times anything is just itself, so I can just put radical 11 over 2. So this would be my final answer. So if you had left it, so a couple things here, right? If you had left it as a decimal, that's okay, but traditionally what we do is that we don't want to mess with the decimal, because what's happening here is we're actually rounding, so we're kind of making the answer a little bit less accurate. So by leaving it in this radical form, it's the more accurate answer, and we're just then reducing it. So this is really the answer that we want to see with this one. All right, now you notice real quick before I wrap up this problem, you notice I kind of left like a big chunk of space here. I wanted to show you kind of 2 different ways, and all it is just about how you organize your paper. That doesn't have anything to do with doing the problem differently. You can work down the page. Some people, though, they don't like having to rewrite this each time, and you saw even me, I made a mistake in not recording the number correctly. So as an alternative, and again, you get the same thing, it's just how you organize it. So instead of having to rewrite the whole problem all over again each time, what I'm going to do is I'm just going to build on this radical part. So 2 squared, which is 4, right? We said that was -40. And then 4 minus -40, right? 2 negatives turn into a positive. So that ends up being 44. And then we already, so we already broke apart square root of 44, which is 2 radical 11. So you notice that I got kind of to the end without having to rewrite any of this stuff. So then I could then just simplify it and say, -2 plus or minus 2 radical 11 over 4, which reduces down to -1 plus or minus radical 11 over 2. So it's same answer, right? Take a look, same answer. It's just it was less writing, right? So some people, all this is just a difference in organization. So I don't show you both to confuse you, but I just know that some people like maybe kind of the tighter, cleaner way of writing it. Which I guess by saying that I'm kind of showing my bias, because I kind of prefer doing it this way. But you can also then work down the page as well. It's up to you. All right, so we will stop here and go ahead and try number 8.